So while we've been talking about how to create or how to carry out significance tests for population means, there is one other type of significance test for means that we're going to talk about in this section. Now, up until now, everything we've been doing is for one sample, and we're still doing that, but it's going to look a little bit different. So this section is all about inference for means, but it's when the data is paired. Now, comparative studies are more convincing than single sample investigations. So for that reason, one sample inference is less common than comparative inference. So study designs that involve making two observations on the same individual or one observation on each of two similar individuals results in what we call paired data. So even though it's two things, they are linked together. When paired data result from measuring the same quantitative variable twice, as in a job satisfaction study, we can make comparisons by analyzing what we say is the differences in the pairs. If the conditions for inferences are met, so we still have the same conditions, we can use these same one sample t procedures to perform inference about the mean difference, right? Mu sub d, where d stands for difference. So even though we're taking two sets of data, we're really finding the difference between them and then using that for our study. These methods are sometimes called paired t procedures. So we're going to walk through an example together. Make sure you have your calculator out. For their second semester project in AP Statistics, Libby and Catherine decided to investigate which line was faster in the supermarket, the express lane or the regular lane. To collect their data, they randomly selected 15 times during a week, went to the same store, and bought the same item. However, one of them used the express lane and the other used a regular lane. To decide which lane each of them would use, they flipped a coin. If it was heads, Libby used the express lane and Catherine used the regular lane. If it was tails, vice versa. They entered their randomly assigned lanes at the same time and each recorded the time in seconds it took them to complete the transaction. Carry out a test to see if there is convincing evidence that the express lane is faster. So while we have two sets of data, right, the express lane versus the regular lane, each set of data is linked together, right? So for this first line, it took the one girl 337 seconds to get through the express lane. It took the other girl 342 seconds to get through the regular lane. We're going to be looking at the difference between the two lanes. So before we get to our four-step process, we are going to find the differences here. Okay, now it's up to you if you do the express lane minus the regular versus the regular minus the express lane. You just have to be very specific about how you're doing it so that when you write your hypotheses here in a little bit, it'll make sense. I'm going to do the difference of the regular minus the express. So I'm going to make another column and call it regular minus express and get that data. I could do this all by hand, but what I think I'm going to do is I'm going to put my data in my calculator. So I'm going to put them in my lists. Let's clear this out. Okay. So I'm going to put all my express lane data in list 1 and my regular lane data in list 2. Will you do this now with me, please? The order in which you put in the data is very important here. You want to make sure that it lines up perfectly with how it appears since it is paired data, right? This number matches with that number goes with that number. So if I'm doing the regular lane minus the express lane, I'm going to tell list 3 to be list 2, so I hit second 2, minus list 1, which is second 1, and I hit enter, and it gives me all of the numbers. So I need to write them down. This is an important step to write it down. Yes, there will be some negative values, and that is okay, because you wouldn't expect all of the one column to be greater than the other, or vice versa. Well, maybe you would, but we're testing here, so we can't just assume. So I've got negative 94, negative 17, 95, 20, 14, 129, negative 39, and then lastly is 42. I could have done all of that in my head or just, one by one in my calculator, but I have a feeling that I'm going to want to have all of this data in my calculator here in a little bit. So let's go ahead and get to our test, our significance test. So we have our differences, and let's go through our 4-step process. So the first thing we want to do is we want to test the following hypotheses. And it didn't give us a significance level, so we always assume that we're going to use 0.05. Okay, so we still have a null, and we still have an alternative. Now, because this is coming from paired data, we're going to be looking at the mean difference. So mu sub d is going to be my parameter. Okay. Now, if we want to see if the express lane is faster, we're going to assume then our null is that they're the same. If they're the same, that means the difference between the two would be 0. Oh, I wrote the wrong symbol then, because this shouldn't be a greater or less or an equal to sign. Sorry. It should be a greater than 0. Now, why would it be greater than 0? Well, hopefully you'll see when we define our parameter. So mu sub d is the true mean difference, right? And we did regular minus express in time required to purchase an item at the supermarket. So why would I have a greater than sign? If we think that the express lane is faster, that means we'd think the time in the express would be smaller than the time in the regular. So if I subtract a bigger number minus a smaller number, you should end up with a positive difference. So that's why I think it's greater than 0. Now, say you had reversed this and you did express minus regular. The only thing that would change then is your alternative hypothesis would be that your mu is less than 0, because you would think this regular would be second, and if you subtract a bigger number minus a smaller number, or excuse me, a smaller number minus the bigger number, you're going to get a negative value, which would make it less than 0. Okay? So now we go through our conditions. Nothing has changed as far as how we write conditions. So let's go ahead and do that. I'm going to pause it so I can write it out. So a couple things to note. If the conditions are met, we're going to perform, it's still a t-test for mu, but it's a little bit different because now instead of a one sample, we call it a paired t-test for mu sub d, where d stands for difference. Now, in the random condition, there are two things that we have to talk about. This is a random sample of times to make the purchases, and also they were assigned to the lanes at random. Both of those things are important to note here. Okay? The next condition is our normal condition. Now, we don't know if the population distribution of differences is approximately normal. And we don't have a large sample size, so what we have to do is we have to graph the differences and look for any departures from normality. So we are going to do a kind of graph. Remember, you can do any kind of graph that you wish, as far as you can do a histogram, you can do a box plot, a dot plot, a normal probability plot. I'm going to do 2 in this case, just so you can see them. So what I'm going to do the box plot first. I'm going to go to Stat, Calc, 1 Variable Statistics, and I'm going to put in list 3. I know it's hard to see on my calculator, but I hit second 3 because I want to find the information for list 3, which was the differences. So I'm going to scroll down and get all my important information. Notice how my minimum is negative 94, Q1 is negative 17, median is 30, Q3 is 95, max is 246. So I'm going to go ahead and make a box plot for that data. When I made the box plot on my calculator, I can see that there were no outliers, so I can just go ahead and plot my 5-number summary above my number line. Because it is such a wide range, I just went by tens and made it as best as I could to show my box plot. I'm going to make a dot plot as well because I want you to be able to see the layout of the distribution as far as any kind of skew. So as you can see from both of these graphs, there is a slight skew to the right. That's what this longer tail shows you, and also my little departures here. But there are no outliers, so it's going to be reasonable for us to use t-procedures for this data. So after we make the graph, we have to say that since it's only slightly skewed, not strong skewed, and there aren't any outliers, it's reasonable for us to use our t-procedures here. Now, the last condition is independence. Okay? Now, here's what we're going to say for that. It's going to be a little bit different than we normally do. So, since we randomly selected the times to conduct the study from an infinite number of possible times, the differences then should be independent. We don't really need to worry about the 10% condition here. All right. So now we have gone through and we have checked our conditions. So now we can go ahead and do our calculations. Now, to do our calculations, we need to know the sample mean and the sample standard deviation for the differences. Okay? So in my calculator, this is why it came in handy to have my data in my calculator. I'm going to go to Stat, Calc, 1var Stats for list 3 and get my mean difference was 42.67 and my sample standard deviation is 84.02. Okay? So let's go ahead and do some math. I ran out of space, so I'm going to do this on the back. Okay. So, my test statistic is T. And I'm going to take my sample mean, which we said was 42.67. My sample standard deviation, which was 84.02. So 42.67 goes up there. What was my claim? I claimed they were the same, which means the difference would be 0. Divide that by my sample standard deviation. Divided by the square root of, now, how many pairs were there? There were 15 pairs. Okay? So, I have 42.67 minus 0 is just that, divided by 84.02, divided by the square root of 15. I get a test statistic of 1.9, let's round that to 7. Okay, so then I need to find my p-value. So using my degrees of freedom here would be 14, right? We're still using t-procedures. So I would use TCDF. This is a greater than problem, so 1.97 would be my lower number. Some big number there. So go ahead and do TCDF in my calculator. Lower is 1.97, big number there, 14. And we end up getting a p-value of 0.034. As for our conclusion, since our p-value is less than our alpha, we reject our null hypothesis and say that there is convincing evidence that the express lane is faster than the regular lane on average. One more video after this, guys.